electrochemical cell and Gibbs energy. The reversible work done by a galvanic cell is equal to decrease in its Gibbs energy. If the EMF of the cell is E and NF is the amount of charge passed and delta Rg is the Gibbs energy of the reaction given by, delta Rg is equal to minus NF E cell. If the concentration of all the reacting species is unity, then E cell is equal to E naught cell. Delta Rg is equal to minus NF E naught cell. By calculating the value of E naught cell, we can obtain the value of standard Gibbs energy of the reaction delta Rg naught. Standard Gibbs energy of the reaction and equilibrium constant are related by the equation delta Rg naught is equal to minus RT natural log K. Conductors. The substances which allow the passage of electricity through them are called conductors. The conductors can be classified into two categories: metallic conductors and electrolytes. Metallic conductors. Those metallic substances which allow the passage of electricity through them without undergoing any chemical change. The conduction through metals is due to the movement of electrons in the metallic crystals. For example, copper and silver. Electrolytes. Those substances which allow the passage of electricity through their aqueous solutions and also undergo chemical decomposition at the same time. The conduction through the electrolytes is due to the movement of ions produced by the electrolytes in their aqueous solutions. For example, acid and base. Classification of electrolytes. Depending upon the extent of ionization, electrolytes are classified into two categories: strong electrolytes and weak electrolytes. Strong electrolytes. These are almost completely ionized in their aqueous solutions. For example, HCl, NaOH and KCl. Weak electrolytes. They ionize in aqueous solutions to the smaller extent and have low degree of ionization. Their aqueous solution contains ions in equilibrium with undissociated molecules. The degree of ionization of weak electrolytes increases with dilution and approaches unity at infinite dilution. For example, NH4OH and CH3COOH. Factors affecting electrolytic conduction. Electrical conductivity of the solutions of electrolytes depends on the following factors. The inter-ionic attraction. These are the attractive interactions between the ions of the electrolyte in solution. Larger the inter-ionic attraction, lesser is the freedom of movement, and smaller will be the electrical conductivity. The solvation of ions. These are the attractive interactions between the ions of the electrolyte and molecules of the solvent. Larger the solute-solvent interactions, greater is the extent of solvation and lower will be the electrical conductivity of the solution. Viscosity of solvent. This factor depends upon the attractive interactions between the solvent molecules. Larger the solvent-solvent interactions, larger will be the viscosity and lower will be the electrical conductivity. Temperature. As the temperature of electrolyte solution is increased, kinetic energy of the ions increases. This results in the increase of electrical conductance of electrolytic solutions. Electrical resistance. Every conducting material offers some obstruction to the flow of electricity, which is called resistance. Ohm's law. It states that the potential difference across the conductor is directly proportional to the current flowing through it. V is equal to IR, or V upon I is equal to R. The ratio of potential difference across the conductor to the current flowing through it is constant and is called resistance of the conductor. Its unit is ohm. Resistivity. It is defined as the resistance offered by the conductor of 1 centimeter length with area of cross section equal to 1 centimeter square. Resistance of any conductor is directly proportional to the length of the conductor and inversely proportional to its area of cross section. R is equal to rho L upon A, where rho is known as specific resistance or resistivity. Electrical conductance. Conductance is a measure of the ease with which current flows through the conductor. It is defined as the reciprocal of resistance. It is denoted by G. G is equal to 1 upon R. The unit of conductance is mho. Conductivity. It is the reciprocal of resistivity. It can be defined as the conductance of 1 centimeter cube of the conductor. It is denoted by kappa. Kappa is equal to L upon Ra. The unit of conductivity is mho centimeter inverse.